Let's talk about derivative notation and interpretation. So we have f prime of x. So f prime of x is the slope of a tangent line to the function f at x. So derivative has multiple names. Derivative in general, we call derivative slope. And in application, you can call that rate of change, and sometimes in physics, we call that instantaneous velocity. In business calculus, people talk about profit, cost, and revenue all the time, right? Especially in business. So in business calculus, they use a function to describe the profit of a business. They use a function to describe the cost. They use a function to describe the revenue. How about the rate of change of this function? So for rate of change, they don't use rate of change of profit. They use a word called marginal profit. So marginal profit means you are simply taking the derivative of the profit function, and then marginal cost, you are simply taking the derivative of the cost function, and marginal revenue, you are taking the derivative of the revenue function. So overall, derivative describe how y changes with respect an independent variable, or you can say derivative means derivative describe how things change. So that describe how y changes with respect an independent variable. So usually we call that an x. So let me give you a couple of examples. So number one, how temperature changes with respect to time. So that is taking the derivative. So first of all, you must have a function that describes the temperature of an object at time t, and then you take the derivative of this function. So that is the derivative. The derivative is using one function to describe how temperature changes with respect to time. Another example can be revenue. So revenue, we have a revenue function that describes the revenue of a business with respect to the number of units sold. So the numbers of units sold, you have a revenue function, you take the derivative of the revenue function, then you get the marginal revenue, and then with respect to an independent variable, which is the number of units sold. So we are using one function to describe how the revenue changes with respect to the numbers of units sold. So how about notation? So derivative has several notation. The two notation we use all the time is y prime and f of x. So y prime and f of x, I use them all the time. And then when we reach to the later on, we will start using dy dx, and then this dy dx is particularly useful, and you should use them in application of derivatives, such as optimization problem. So when we do optimization problem and related rate, so we use dy dx a lot because that helps us that tells us what we are doing. So if you are using y prime, that is less meaningful compared to dy dx. So for dy dx, you can pull the y out. So the dy dx means the derivative of y with respect to x. You can pull the y out if you want. So we are taking the derivative. The d in the numerator stands for derivative of y, and then with respect to x. And then this notation is called Knightness notation. So the Knightness is named after a German mathematician. Knightness notation. So let's play around with the notation. So we have y equals to f of x equals to x squared. So this is a parabola. So f of x equals to x squared. And then what about the derivative? The derivative, you can either use the limit definition of derivative, or you use the shortcut. So for the shortcut, basically you bring the 2 down to the front and then take the second power minus 1. So that's why we have 2 in front of the x, and then 2 minus 1 is the first power. Okay, so it doesn't matter what method you use, but don't worry about that. So the purpose of this video is talking about notation, so we are not talking about how we get to the derivative. So we have y prime, so this is one of the notation, and then f prime of x, and then you can use dy dx, so that is the derivative of y with respect to x, or you can pull the y out, so the result is equals to dx. So how about this? I want you to ask you to find the derivative at a specific point. So what is the derivative of the parabola when x is equals to 5? So we always write f prime of 5. You take the derivative, the 2x is one function to describe the slope of the parabola at any x value, and then f prime of phi, that is the derivative of y with respect to x at x equals to phi. You can call that such that x equals to phi. So what you have to do is you plug in phi to the notation. So this one are such that x equals to phi. I don't use that a lot. I always use f prime of phi. So you plug in a phi to the derivative, that is equals to 10. So you have a parabola. When x is equals to phi, you have a y value phi 25, right? So phi comma 25 is a location, is a point on the parabola, and then at this point, the slope of the parabola is equals to 10. Let's put the notation on a small application problem. So let's say a cup of hot coffee is placed on a desk. The temperature, I use Celsius, the temperature function g of t describes the temperature and time t. So I want you to explain what g of 2 means. So what is g of 2? So g of 2, so we are not doing any derivative yet. So g of 2, so what is g of 2 mean? So g is a temperature function. So g of 2, whatever that equals to, this is the temperature of the coffee after 2 minutes. So that is the temperature of the hot coffee after 2 minutes. So whatever g of t equals to, you plug in t to the function. So after 2 minutes, that gives you the temperature after 2 minutes. So I call this a position or displacement. When time is equals to 2, you have to tell me where you are, or in this case, I should say when t is equals to 2, you have to tell me the temperature of the coffee. All right, and then the next one is g prime of t. So we have g prime of t. What does that mean? First of all, what is g prime of t? So g prime is the derivative, which derivative means the rate of change, right? So this is rate of change. Very important words, rate of change. Sometimes I will just call this ROC, rate of change of the temperature at time t. So the temperature of the hot coffee is changing. We are using one function, g prime of t, to describe how the temperature changes at any time. Okay, one function to describe the whole thing. Describe how temperature changes at a time. And then the dg dt, how about the unit? So when it comes to application problem, I am very strict with the unit. I want every student write down what the unit is. So g prime of t, so this is one of the ways to write it, right? And then it can be the derivative of g with respect to time t. So t in the denominator, I know that is the independent variable. We are taking the derivative with respect to t. With respect to t means I am treating t as an independent variable. And then what is the unit? Is the unit a Celsius, or the unit is just a minute? Oh, I forgot to tell you. After t, the t is in minutes. So g, that tells you when g is equals to 2. So what's the temperature of this? At t equals to 2, you get a temperature that is in Celsius, right? So we have Celsius on top and then time in the denominator. So this is Celsius per minute. So that is the unit of g prime t. Next, we have g prime of 3. So what does that mean? So we have g prime of 3. Another way to write this is you have take the derivative of g with respect to t, and then such that time is equals to 3 minutes. So this is the rate of change. So this time let's use ROC. So rate of change of the temperature after 3 minutes. So what about g prime of 3 is less than 0? How about g prime of 3 is less than 0? What does that mean? That means 3 minutes later, so when t is equals to 3, the coffee is cooling down. So the coffee is cooling down because the temperature, the G prime, is decreasing. Alright, so that is the end of this video. If you like it, you think this is helpful, give me a like, share, and subscribe, and I will see you all in the next lesson. Signing out.